Hi friends, today we learn about digital number systems. First of all, let us learn the definition. Digital number system is used to represent any information in electronic devices. Actually, it is a language of digits, as in computer accepts only the language of digits. Binary, these are the common types: binary, decimal, octal and hexadecimal. In this episode, we will try to cover binary and decimal. Base, it is the positional value of a digit in a number. For example, the base of binary system is 2, as there are only two digits 0 and 1. Binary is the common source used in laptops and computers. Conversions. This is the main part of this episode. Digital digits to binary digit. Decimal. We know that binary digits have only two numbers 0 and 1 respectively. Decimal means 10. There are 10 numbers embedded in it. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 respectively. To convert a decimal digit to a binary digit, we need to divide it with its base. Now let us take an example of 17. 17 is written in this way. Here the 10 describes that it is a decimal digit. We need to find the value of the 17 in decimal digit to binary digit. We need to convert it. The common ways we use to divide is in this process. The reason why we are dividing it with its base is the base is very important, so we are dividing it with it. In this episode we will convert decimal digit to binary digit. I am using an LCM method to divide it. Now observe it carefully. 2 8 times is 16. So 17 minus 16 is 1. So I am writing 1 beside it. Now 2 into 4 is 8. So there is no remainder left and I have written 0. 2 into 2 is 4. So there is no remainder left. I have written 0. 2 ones is 2. So again there is no remainder left. Here, as 1 is less than 2, I have taken a number less than 1. So 2 into 0 is 0. So 1 minus 0 will be 1. So I have left the reminders. So I have written here that these are the reminders. So they also play an important role in this episode. 1710 is 10001 in binary digit. When you divide a decimal digit with its base, that is 2, you always get the answer only in the digits 0 and 1. You may try any other problem, not only 17, but you can take any of the problems or any of the examples. Now, as we have learned how to convert a decimal to binary, now we should learn how to convert a binary digit to decimal digit. First of all, let us learn how to represent a binary digit. So for representing a binary digit, we first need to know its weight. Now see it properly. 11001. I am taking this as an example. I have drawn a box and divided it into 5 parts. I am writing each number in the box. See, this is called the decimal point. Just imagine that there is a decimal point. Actually there is no decimal point, but imagine it. Here we need to find the weights. So I am writing the weights. The weight of number before the decimal point will be 2 power 0, before it will be 2 power 1, before it will be 2 square, before it 2 cube and before it will be 2 power 4. The weights of binary digits will always be in the form of 2 to the power of n, because 2 is the base. Now here we have numbers before decimal point, but after decimal point we are not having any numbers. So let us take an example having numbers after the decimal point. Now I have taken the example 11001.001. Again I have drawn a rectangle box and divided into 8 parts. I have written the numbers 11001. and placed the decimal point. After it are the numbers 0, 0, 1. Now, before finding these values, let us find the weights of numbers before the decimal point. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, as you have learned before. Now, the weights of the numbers after the decimal point will be 2 power minus 1. After it will be 2 power minus 2, and after it will be 2 power minus 3. You may be wondering how to find the value of 2 power minus 1 and having the exponent form in minus forms. You will learn it at the end of this episode. Please pay patience and watch it carefully. Now we will turn a binary digit to decimal digit. I have taken the same example for your convenience. Now please see this. Here I have taken the first digit 1. Now I should find the weight of it. So this will be 2 power 0, 2 power 1, 2 power 2, 2 power 3 and 2 power 4. See, 2 power 4. So I will multiply it 1 with its power. It will be 1 into 2 power 4 plus I will add it to the weight of next number 1 plus into 2 cube plus 0 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0. Now 2 power 4 is 16. As we are multiplying with 1, we will get the same answer. 2 cube is 8. When we multiply any number with 0, we are getting 0 as the answer. So it will, for these both equations, the answer will be 0. 1 into 2 power 0. Actually 2 power 0 will be equal to 1. So 1 into 1 will be 1. Now it will be equal to 24 plus 1, which will give us 25. So 1101 in binary digit is 25 in decimal digits. Now here we are not having any point, but we imagine that there is a point. Now the number having with a decimal point, we will be trying to find it now. I have taken the example, same example which I have taken here. See, 11001.001. Now we will do the same process. 1 into 2 power 4 plus 1 into 2 cube plus 0 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0. So now after it, 0 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3. Now 2 power 4 is 16, 2 cube is 8, 0 into 2 square is 0, 0 into 2 power 1 is 0 plus 1. Now 0 into any number will be 0 and 0 into any number again 0. 2 power minus 3 can be also written as 1 by 2 power 3, which will give us 1 by 8. The value of 1 by 8 is 0.125. So when we add these both, we get 25.125. So 11001.001 in binary digits will be 25.125 in decimal digits. If you have carefully watched this episode, you may have learned what are digital number systems, what are the common types, and what are their bases, how to find their bases, what is the weight of an binary digit, the conversions from binary digit to decimal digit and decimal digit to binary digit. Thank you for watching this video.